Welcome to the first of our video lectures following the changes in the classroom. This video is a very brief kind of introduction to a few things that I want to cover prior to getting into the rest of the class. And really what I'm doing is I want you to become comfortable with reading the maps that you're going to be seeing in the world for the next several weeks. And so I want to return something at the beginning of the class. You will be tested on this in the very short quizzes. So get down the important idea, and I'm really going to hit on them, so don't worry about that. All right, first of all, remember that you're going to be seeing a lot of maps that are going to show the COVID-19, the coronavirus, as it moves through our population. And I want you to be able to read those maps critically and carefully. This is by no means diminishing the importance of what's going on. But again, I always want people to understand what they're looking at and how to read it. So, first of all, when we talk about this, remember, for the quiz, when we talk about counts, and you're going to see this on a lot of maps, it's the number of events within an enumeration unit. And remember, the enumeration unit, okay, is the geographic unit that the count is applied to. So, for example, we might see counts per county in Pennsylvania, so counties would be the enumeration unit, or counts by state in the United States, again, then states are the enumeration unit, or counts by country. And each one of those is important. The important thing, though, to remember is that enumeration units vary in size. And so it's not at all surprising that there are more cases in New York than there are in Rhode Island for a number of reasons, but that's important. The other way that we can think about this, as opposed to just counts, is the idea of rates. And we don't see much of this today, and I think it's important that we begin to see it. Rates mean the number of occurrences of phenomena, so number of people that are infected per reference phenomena. That is, number of people infected as a percent of the total population. What is that ratio? And that's really important to understand. Do we have a high proportion of the population infected, or do we have a low proportion of the population infected? The third way that we can sometimes see this, and you will not see this, and I won't even show you an example of this today, but we might be looking at the densities. Densities are counts of phenomena per unit area. And so oftentimes this is events per square kilometer. And we might see something like doctors or hospitals per square kilometer. That might be something that's going to come up later on. Okay, so let's take a look at these. The other thing that we want to think about is how these things appear on a map. So most often today, what you are going to see in the news and in the media is that we're going to show counts. Remember I said counts, and we're going to see that by what we call a graduated symbol map. And what this means is that the size of the symbol, so again we can see this right here, the size of that symbol is graduated based on the number of something that we're talking about. Again, for example, confirmed cases. Little tiny dots might mean anywhere between 10 and 100 cases. Really big dots, something greater than 25,000. The thing that you have to remember about this is that that big dot may make two places look very similar, even though they are actually somewhat different. Now, some maps will actually show proportional symbols. It's a special type of graduated symbol in which the size, the radius, the diameter of the circle is actually a function. That is, it gets increased by every single value. So there is a biggest one and there is a smallest one, as opposed to classes, which is what you see here. Okay, so graduated symbols. Always be aware of what the biggest size is and what the smallest size is and how those intervals are. Now, we can also see what we call, again, we talked about this earlier in class, a choropleth map. And the important thing to note about this is the choropleth map shows a quantity, reported cases, but by color. And so darker colors typically mean more of something. But again, remember that this is about the classification, the number of classes. So look here, and we see that none, okay, the white, and we don't have, unfortunately, all of the states in the United States now have some. But we have 6 to 50, so that's a class that is 44 units. The next one is 49 units. The next one is 500 units, or I'm sorry, is 400 units. The next one is 500 units. And then the next one is 4,000 units, and this one goes all the way up to what we have in New York now, which is over 20,000. So the intervals are not equal. They get bigger as we go up, and that makes some states look similar that really aren't very similar. Okay, now I want to do a little comparison, and I want you to begin to understand why some of these things matter. So this is one of the maps that's very common to see, and this is the number of cases, and each of these graduated dots represents the number of cases in each state. And as you can see here very clearly, most of the middle of the country in the West have very few cases. New York is very large. Washington and California are also very large. But if we look at that a little differently, if we take that and put it into a choropleth map that shows the data, remember the term normalized. Normalized means when we take a ratio. So in this case, what I've done is I've taken the number of cases in each state, and then I've divided it by the total population in that state as of 2018. And what you'll notice is that we get some really small numbers. In other words, the ratio, the proportion of people in the state that are infected, become very, very small. But the other thing that begins to show up is that we begin to see that the country looks a little different this way. Obviously, Louisiana, New York, and Washington still come up very high, but the rest of the states, and most notably California, doesn't look as significantly impacted, and that's because it has such a large population. So you want to be aware of how the data is presented and also what's being seen. Is it total counts? Is it ratios? Or is it something else? Okay, that's it for this one now. Again, for your notes and for the quiz, I'm going to go back very quickly. You need to understand the word normalize. Normalize means to divide a count by some reference population. We're going to look at choropleth. A choropleth means that it's counts or ratios, but it's done by color. Okay, so in each, and again, enumeration unit, you need to know that term. Enumeration units are states or counties. It's whatever we put the count into. Graduated symbols, again, the size of the symbol indicates the count. And then, of course, remember, counts, rates, and densities. Counts are simply numbers in an enumeration unit. Rates are a ratio of an occurrence per reference, and densities are counts per area. That's it for this lecture. We'll see you next time.